Section 4.2, we are going to study a new special event. We call this mutual exclusive events. What does that mean? Mutual exclusive, using human being language, that means those two events cannot happen at the same time. So in other words, there's no way for them to be true at the same time. So to give you some example, you understand what are mutual exclusive events. Say our first event A, say today is Thursday, like that's one statement, right? You can say that's like one event, right? We know that event as of today, right? That's false, right? Today is Tuesday, right? Today is Thursday, that's a false statement, right? And then event B, today is Friday, right? My question here is that possible for both statements, right? Event A, event B, for both of them to be true at the same time? No way, right? There's no way for those both statements to be the true at the same time, right? I mean, we are living the regular three-dimensional plus the time space, right? I mean, as long as in one location, one, time, right? Regular time, right? So someone was trying to say different time zone. One region, one particular place. You only have one time zone. Is that right? So, if it's at a different place, yeah, that's possible. But the same place, no way, right? Normal case. So that's in that case, we call this event A, event B to be mutual exclusive. Okay. And then how about another event C? Today is not Thursday, right? If we compare A and C, everybody, is that possible for them to be true at the same time? Today is Thursday. Event C, today is not Thursday, right? It's impossible for them to be true at the same time, right? Because what? Because they are opposite to each other. So that's what we call complementary events. If you remember previously, we talked about that, right? They are opposite to each other. If A is true, the event C has to be false, right? If the A is false, the event C has to be true, right? They are opposite to each other. There's no way for them to be true at the same time. So we say A and C, they are mutual exclusive. Now, how about the B and C, everybody? Today is Friday, and C, today is not Thursday. Yes, it's possible for this event B and C to be true at the same time, right? Say on that day, it is a Friday, then both statements, they are true, right? So in that case, event B and C, they are not mutual exclusive. Okay, so we also have a note here that any event, E, remember we are using capital letter E for any event, right? And it's complementary event, we are using the capital letter E bar for that, right? They are always opposite to each other, so which means they are always mutual exclusive. So hopefully that's clear. Now we are going to study further in terms of for that situation, how do we calculate probability? Remember, for this class, we will have a lot of probability questions trying to answer, right? So the first one we are going to study addition rule, right? So what that mean is for the two events, A and B, right? If they are mutual exclusive, remember from the definition itself, that means those two events, they cannot be true at the same time, right? But using a picture, remember one picture was more than 1,000 words, right? So what does that mean? That means if you have this picture here, if you see that, right? That's a square here or rectangle. Ideally it's a square, right? So that covers all the possible cases. Now, if A, B, they are mutual exclusive, that means what? That means those two events here, there should be no overlap. They should be completely separate. So that's the image visualization you can see. You can kind of help you remember what do you mean by mutual exclusive? Means what? That picture, they are separating from each other. No overlap. So in that case, if we are trying to calculate everybody, probability of A or B, right? What do we do? Right? So that means we want to cover probability of A or B, right? We simply add how many cases here for the A, what's the corresponding probability here for B? Simply add them together. That's the formula, right? Easy, straightforward, right? We have some example here later to, kind of show you when you plug the numbers, right? To help you understand that. Now, the question is, what if it's not mutual exclusive, right? Like this case here. If it's not mutual exclusive, what's happening? So you can use that image here. That means what? That means there will be some overlapping here, right? So you see that here. There will be certain region, right? Like this, the highlighted region here, right? So that region is in A, is also in B. So in other words, that region here, A is true, right? B is also true. So that what we say, right? Because they have overlapping A, B, they are not mutual exclusive. So in that case, how do we calculate probability of A or B? Everybody, pay attention. This one is a little bit tricky here. Wake up. So that means we can calculate if we, focus on the picture, right? We want to find out the probability of A or B, right? So which area we are looking for. So if I want to draw that picture, probability of A or B is like we are looking for that area. Everybody follow me, right? That's the stuff we want to cover, like that, right? So in other words, if I'm trying to use the probability of A, that means what? That's like, let me see if I can use different color here, right? Let's use this color here, right? Probability of A, that's like this one here, right? As a probability of A, right? That's what we have here. And then probability of B, let me use that one. That's like this one here, right? So what's happening here is like, if we add these two parts together, everybody, what's happening here is like this area, we count twice. Remember when we calculate probability of A, like that is right? Like this area, we count one time. And then later when we calculate probability of B, this area is counted again. So it's double count, right? So that's not good. We want to subtract that double count. So that's the reason you see the minus here, everybody. Minus, right? Subtract. Subtract what? Subtract this region here. What is that region? That region is what? A is true, B is also true. So you see that subtract A and B, everybody. Follow me? Subtract A and B. Okay, so that's the formula we are learning tonight here. The first formula here. Technically the second one, right? But this one here is I would say it's the first one that are a little bit complex, but follow that picture, hopefully it's more clear why we have to subtract. Everybody? So now we are going to apply some examples, like using that formula to do the calculation of the probability case. Okay, so for that, mutual exclusive. Now let's apply this example here we have, right? So this example here, what we have, we are given the information about, like usually you will see that from homework or from the exams, right? Like some table that tells you they have this information available, like this one. They usually will give you that table, right? How do we read this table here? So we can read this like 7 means what? 7 female nurse, right? 1 male nurse, 3 female physician, and 2 male physician. Everybody, right? Altogether, how many people? 13 people, right? So those are the information we are given out of those 13 people, right? Also, if we summation each row here, like how many nurse, right? 8. How many physician total? 5, right? How many female total? 10. How many male total? 3. Everybody? So during the exam and the calculation, usually we require this calculation by yourself. Find out like how do you get 8, 5, right? Everybody, when you add 8 to 5 together, what do you have? 13, right? When you add 10 plus 3 together, you got 13. Everybody, you can verify your result. Did you make a mistake or not, right? Say, for example, if some of you like do the calculation, 7 plus 3 got a line here, for example, okay? Then you got, when you added 9 plus 3, you got 12, right? Not the same as 8 plus 5, you got 13. Something's not right, everybody. That way you can double check your calculation if there's any mistake or not. Okay. Now, if this is the information we are given, right? We are given this information here out of those 13 people, right? We are given. Now, we want to solve any probability questions, right? So the first question here is, we are going to randomly select one staff, right? One staff out of that 13 people. So randomly select, very, very, very important. When we say randomly select, everybody, that's very important, right? So randomly select one staff out of just 13 people, find out the probability for that staff, right, to be nurse and male. Everybody? Remember, whenever we calculate the probability, like what's the first thing come into your mind? Probability is something divided by something. Follow me? Right? So you randomly select one person out of 13 people. How many choice you have? In the denominator is all possible choice you have. How many total possible? You select one out of 13. That's 13 in the denominator. In the numerator is a number of cases that you are asking. You're asking how many cases there are male and nurse. Everybody, how many male nurse we have? 1, only 1. So the answer is 1 out of 13. Very straightforward. Everybody, follow me? Right? So that's the way to answer these probability questions. Okay, now second question is going to be a little bit tricky or difficult. Everybody, if you care about the final, care about the exam, okay, so pay attention here. So question number 2, when we put it like dot, dot, dot means we copy everything from the previous row, okay? I'm lazy, reasonable lazy, okay? I copy everything from the previous row. Find out the probability of randomly select the staff to be nurse or male. Everybody, reasonable lazy, right? Those keywords I want to write, right? Highlight those so you know the difference, right? So it's a probability question, right? Something divided by something. We know that, right? Now, we are trying to answer using the formula we just learned, right? Probability of like A or B. That are keywords here. Or kind of remind you, can we use that, right? A or B. Everybody, remember, if we are doing that, then we have to assume, like, what do you mean by this is event A? You want to define that, right? So we define event A to be that staff you selected. You want that staff to be nurse, right? That's the event we're talking about. Event B, we want that staff to be male, right? So in other words, we convert this human sentence, right, to mathematical formula. Everybody, why mathematics is difficult? Why statistics is difficult? Because they are not human language, right? I mean, they are stats language, they are mathematical language. So there's a gap, and this gap sometimes make us confusing, right? So sometimes we need those translation, right, transformation to help us understand better, right? That's one of the goal, or why we are here, right? Instructor is trying to explain the concept using human language, right? So we translate that question to a formula, which is a probability of A or B. Remember the formula we just learned, right? Probability of A or B is equal to that formula here. What does that mean? That means we simply calculate each piece, then we are good, right? So we calculate what's the probability of A first, right? So what's the probability of A? That means I randomly select one person, right, out of those 13 people. What's the probability of that person to be nurse? As A, right? So remember, probability is something divided by something, right? Something divided by something. You randomly select one person out of 13 people. How many choice in the denominator? 13, right? In the numerator is how many cases you are getting nurse, right? How many nurse we have here? We have altogether 8. So that's 8 out of 13. So far, so good. And then similarly, we calculate what's the probability of B, that is that person to be male, right? So we randomly select one person out of 13 people. How many choice we have? 13, right? That's the denominator, all possible situations. Now in the numerator is number of cases we are asking. We are asking the male, right? How many male we have? We have 3 male. 3 male. Everybody? So that's 3 over 13. Okay? So now we figure out what's PA, what's PB, and masterpiece here. What is A and B? Everybody? What is A and B? What does that mean? In human being language, that means we want that person, right? Randomly select one staff. We want that staff to be nurse, also a male. So it's a nurse and male. Everybody, you see? That is actually what we just asked in the question number 1. We know that the probability is what? 1 over 13. Everybody, we plug that here. What's the answer? 10 over 13. Everybody, so hopefully it's clear. How do we plug into this formula here, calculate each part? Got an answer here. 10 over 13. Everybody, there is another shortcut for this 2x2 case. Okay, we can do that a relatively easy way. If you care about that, here's the shortcut to answer this question, right? So in other words, to solve this problem here, we have 2 methods, okay? Which method you want to apply here is totally up to you, right? This way here, formula way, always work, always. And the other one, which I'm going to introduce, is what is this one here. So we are trying to find out what's the probability of randomly selected staff to be nurse or male, right? Nurse or male. Probability is something divided by something. Remember, right? That's what we, right? Something divided by something, right? We know the denominator is always select 1 out of 13. So denominator is always 13, right? I'm trying to answer this question directly, everybody, right? Now we know the denominator 13, okay. How about the numerator here? right? How many cases that they are nurse, also they are male? Everybody pay attention. How many, if you pay attention here, right? How many nurse here, everybody? We have 8 nurse, is that right? And then how many extra male, everybody? We have 2 here. We cannot include that one because that is included in the nurse. Is that clear? So when we check how many nurse or male, right? That's in the numerator we're asking. So how many nurse here altogether we have? We have 8. And then plus extra 2 males. So altogether, how many? 8 plus 2, that's 10. The answer is 10 over 13. Everybody follow me? So we still got the answer 10 over 13. Okay, so that's the way we can also do that. That's the answer here, 10 over 13, right? This way here, you kind of like read the answer directly from everybody. This table here is what? 2 by 2 table, okay? If it's 2 by 3, 3 by 3, or even more complex, then you may not be able to read this directly, I mean, as I mentioned earlier, right? So in that case, we better use this formula, right? Calculate every single items and solve that. Okay,